Good day, students. Welcome to part one on differentiation practice. I'm going to be going over some AP list questions, focusing mainly on the process of differentiation. So let's take a look at question number one. It states that if f of x equals x times the square root of 2x minus 3, then f prime of x is. So you can see that this problem involves the product of two functions. We have the linear function and a radical function that's composed with a linear function. All right, so we can clearly see that this is a product rule example. So this, let's call this u, and this entire function here is v. We know what the product rule is. uv prime is vu prime plus uv prime, or you can do it in the other order. That doesn't really matter. All right, so let's go ahead and apply that to this situation. F prime of x is going to be v, which is the square root of 2x minus 3 times u prime, derivative of x is just 1 times 1 plus u, which is x, times the derivative of the square root of 2x minus 3. We can write it as an exponent, but you also remember this shortcut. If you have square root of u prime is equal to 1 over 2 root u. Okay, so that's a shortcut for applying the power rule to a radical situation like this. Okay, all right, so let's use that here just to save time. So if we differentiate the outer function, which is a square root, it's going to become times 1 over 2 times square root of 2x minus 3. Okay, now we have to be really careful here. We do not want to forget that we are applying the chain rule here. So we have to differentiate this linear function in here. When we differentiate that, that becomes times 2. Okay, now let's simplify. This becomes the square root of 2x minus 3 plus, these two 2's cancel out, x over the square root of 2x minus 3. Okay, we can put this over 1. All right, now we need to find the LCD of these two. So we can just multiply this term here by the square root of 2x minus 3, top and bottom. So we have common denominators. In the numerator, if we multiply roots 2x minus 3 times root 2x minus 3, you're going to have roots 2x minus 3 squared. So the roots and the squares cancel out. And then you'll be left with 2x minus 3 plus x. And they have the same denominator, which is going to be roots 2x minus 3. That's the common denominator. 2x minus 3. Okay? And we'll simplify this. We're going to get 3x minus 3 over the square root of 2x minus 3. And our correct answer is option letter A. So you just have to be careful here not to forget to apply the quotient rule, the chain rule when differentiating a composite function. Okay? All right, let's move on to question number 2. For question 2, we're given a function f of x equals negative x to the third plus x plus 1 over x, and we asked to find the derivative at x equals negative 1. Okay, so let's go ahead and rewrite this in a way that enables us to use the power rule for every single term. So we have f of x equals negative x to the third plus x to the negative 1. Okay, now let's differentiate this function. F prime of x equals negative 3x squared plus 1, and then the derivative here is going to be negative x to the minus 1, minus 2. All right? So this is the derivative. Now we're going to evaluate the derivative at x equals -1. Just simply plugging in -1 into the derivative. F prime of -1 equals -3 times -1 squared plus 1 minus -1 raised to the -2. Okay? Now this becomes, if we simplify this, well, first term here we have -3 plus 1, and then this becomes minus, if you reciprocate this, is 1 over -1 squared. Okay? So this becomes -3 plus 1 minus 1. So this is a really tricky problem with the negatives and the exponents, so you have to be really careful here. All right, so finally we have -3 plus 1 minus 1. The ones cancel out, and your final answer is -3. So our final answer is option letter D. So you can see how you can easily get +3 if you made a slight mistake with the sign. So you have to be really careful when working with negative numbers on the AP exam. All right, let's take a look at question number 3. We are asked to find the derivative of cosine square x to the third. Now this is assessing our ability to accurately apply the chain rule when you have multiple functions composed with each other. In this function right here, we have a composition of a square or a quadratic function, a square function, we have a trig function, and then we have a cubic function. So we have 3 functions that we are dealing with here. So we need to differentiate twice before we get to the innermost function. All right, so rewriting this in this format will really help you differentiate this function accurately. So let's rewrite it as d dx of cosine x to the third, the bracket here, raised to the second power. Okay, so you see we're going to first of all focus on the square, holding this fixed, and then we'll go into the cosine, and then innermost function x to the third. All right, so let's apply the chain rule here. So this is going to yield, starting with the square function, 2 times cosine x to the third. So we differentiated the outermost function, holding the inner function fixed. Next, we're going to differentiate cosine. We know the derivative of cosine is negative sine, right? So negative sine, holding the innermost fixed, x to the third. And then to finish it up, differentiate x to the third. You get 3x squared using the power rule. Okay, and then if you simplify this, 2 times -1 times 3, you have -6x squared. And you have, let's write sine x first, sine x to the third, cosine x to the third. Okay, so you see how you apply the chain rule in this situation. Our final answer is option letter D. All right, let's take a look at question number 4. So here we have, it says if x squared plus y squared equals 25, that's the equation of a circle, obviously of radius 5. What is the second derivative at 4, 3? All right, so this is assessing our ability to differentiate implicitly and to carry out higher order derivatives. In this case, the second derivative. All right, so let's start out by looking at the first equation, x squared plus y squared equals 25. If I differentiate this equation implicitly, I'm going to have 2x plus the derivative of y with respect to x is going to be 2y times y prime. Okay, if you differentiate x with respect to x, you have 2x times 1. equals derivative of 25 is 0. If you solve this equation, isolate y prime in this equation, you're going to have y prime equals, you subtract 2x from both sides, 2x, negative 2x, and divide both sides by 2y. And that follows that y prime is equal to negative x over y. This is the first derivative, okay? Write that down again. Negative x over y is your first derivative. Now, we need to find the second derivative and evaluate it when x is 4 and y is 3. So we're going to differentiate this function again. So how do we differentiate this? How do we find the derivative of this derivative? We can clearly see that this is a quotient of two functions. So we can call the numerator function u and the denominator function v and use the quotient rule. We know what the quotient rule is, right? U over v prime is equal to vu prime minus uv prime over v squared. All right? So let's go ahead and do that. Go ahead and do that here. So we're going to have y double prime equals v. V is y. Okay, we have a negative in front right there, so let's put a negative out here, and then we'll distribute it later. Let me write this again. So we have minus. All right, v is y. U prime is the derivative of x, which is just 1, minus u. U is x times the derivative of v is y prime over v squared, which is y squared. Okay? So let's simplify this. Let's see. We know that y prime is negative x over y. So if we want to simplify this result here, we'll have negative y minus x instead of y prime. We're going to put negative x over y, okay, divided by y squared. Simplifying further, let's distribute the minuses in. We have negative y. This minus times that minus is going to be positive, times this minus is going to become negative, minus x squared over y squared. Okay? Now to eliminate this fraction in the numerator, I can multiply the numerator and the denominator by y. So times this by y, times that by y, and distribute. That will yield, let's see what we get here, because we're multiplying this entire numerator by y. Okay? So that gives us negative y squared minus x squared over y to the third. All right? So this is a expression for y double prime. Y double prime is equal to that, negative y squared minus x squared over y to the third. We have to evaluate this at 4, 3. Okay? So let's go ahead and do that. So y double prime evaluated at 4, 3 is going to be negative 3 squared minus 4 squared over over 3 to the third. All right, and then when you work this out, you have negative 9 minus 16 over 27. And your final answer will be negative 25 over 27. Answer is option letter A. I almost selected E. A is the correct answer. All right? So that's that. All right, let's take a look at question number 5. This is another chain rule problem that can be simplified using the properties of logarithms. All right, so given f of x equals the natural logarithm of um, x squared minus 1, we are asked to find f prime of x. Now there's a long way of doing this using the formula for absolute values, and there's a shorter way which involves um, using the properties of logarithms. Okay, so you want to remember the fact that if you have an absolute value of, let's say, a variable x, that's the same thing as um, taking the square root of the square of x. It doesn't really matter the order. It could be the square root of x or the square root of the square of x, and that's what equal to the absolute value. So if we apply that here, we can rewrite f of x as the natural logarithm of x squared minus 1 squared, the square root of x squared minus 1 squared. Okay, you can write it like that. Now we can also go further and write this as a natural logarithm of x squared minus 1 squared raised to the 1/2. Okay, now using the power property of logarithms, we can write this as 1/2 times the natural logarithm of x squared minus 1 squared. And then we can also apply the same property again and power this down. This becomes 2 times 1/2 of the natural logarithm of x squared minus 1. You can see these two cancel out nicely. So if we have f of x equals the natural logarithm of x squared minus 1, we can differentiate this with ease. Okay, remember that the derivative of ln is 1 over x. So if I find the derivative here, f prime of x, you have to be careful and do not forget to apply the chain rule here. Okay, so because we have two functions, we have a natural logarithm function and a quadratic function. So if we do the natural logarithm function first, we have 1 over x squared minus 1. Applying the chain rule to the quadratic inner function, that gives us 2x. And our final answer is 2x over x squared minus 1. Final answer is option letter D. Now let's move on to the last problem in this installment. Problem 6. Do not forget to subscribe so you can get updates to the future installments. Alright, so let's look at number 6 here. We have f of x is e to the 2x over 2x, and we're to find the derivative. Now f of x equals e to the 2x over 2x. If you inspect this, we have the quotient of two functions. An exponential function, which is composite in the numerator, and a linear function in the denominator. So we can simply call this u and call this v. And we know that u over v prime, we talked about this before using the quotient rule, is vu prime minus uv prime divided by v squared. All right, so let's apply that to this problem. V, let's change that color. V is 2x, so we have 2x times u prime. Now when we're looking for u prime, remember the derivative of e to the x is e to the x, so we have e to the 2x. Using the chain rule, we have to differentiate this composite function right here. So e to the 2x times 2 minus u, which is e to the 2x, v prime is the derivative of 2x, which is just 2, that divided by v squared, okay, which is 2x squared. This is not a difficult problem, it's just the little mistakes that can get you. All right, so we have it set up like this. Let's go ahead and simplify that. We have If you notice, 2 is common, and they're both terms in the numerator as well as e to the 2x. So I can factor out 2e to the 2x, and I'll be left with 2x minus 1 divided by 2x squared. And I can reduce further. I can cancel out. Actually, I made a mistake in the denominator. If I square 2, 2 squared is 4. So let's put the 4 there. Alright, and then if I can reduce. 2 goes here 1, and 2 goes here twice. So twice. And our final answer is going to be e to the 2x times 2x minus 1 divided by 2x squared. Alright, so we can see that our correct answer is option letter E. Okay, so that's that. Thanks so much for taking the time to watch this presentation. You can feel free to subscribe to my channel by clicking up here. And please post a comment to let me know what you think about this clip. More clips can be found on myserve.com. Thanks again for watching, and have a wonderful day.